Hi, I'm Luke, and in this fundamentals training module, we're going to take a look at the high-speed CAN network. We'll talk to you about the principles and explain the function on how the high-speed CAN works. The CAN communication system, known as Controller Area Network, is a network that sends and receives information between control units. Transfer occurs between each module at a high speed and are sent serially one message after the other. The most common name for this system is a bus, binary unit system. The information can be transferred as required or periodically. For example, if I press the brake pedal or select drive in an automatic vehicle, this is known as an event, and the data is sent on request from the corresponding control unit. Periodically is essentially real time, where the data is sent and constantly adjusted. For example, the TPS or the tacho reading in the instrument cluster. Think of the old days where we had Morse code, where there is a sender and this message gets sent to multiple receivers. The message was received in dots and dashes, then converted into letters. These receivers can choose to ignore the message or receive it, depending on the current situation. This is exactly how the high-speed CAN works, but much faster, where instead of dots and dashes, the control unit looks for high and low voltages, or ones and zeros. The message usually consists of a header, which contains information about the sending module and the data. Next comes the data itself, followed by the checksum, which confirms the message is valid. Messages can contain more than one piece of information. For example, engine speed and vehicle speed. Control units can decide if the message is important, and if not, the control units will just simply ignore that message. When the messages get to the end of the bus, they just stop. This is done by terminating resistors. When a message is sent, the 120 ohm terminating resistor prevents that signal or message bouncing back through the bus network. These two terminating resistors are in parallel and give a resistance of 60 ohms at the DLC. If a high-speed bus needs to send a message via a low-speed bus to another control unit, it needs to go through a gateway. This allows communication between the buses. For example, if a high-speed signal coming out of a traction control module needed to get to a low-speed bus, it would have to go through a gateway, which in this case is the BCM, to be able to get to the instrument cluster via the low-speed bus. The high-speed CAN network sends signals that are usually 500 kilobytes per second. The electrical signals that are sent on the high-speed bus are in a form of a binary code. This is the ones and zeros I mentioned earlier, 1 being on and 0 being off. The signal is in a form of a square wave. We're using 3 channels on the oscilloscope, where high-speed high is in red, high-speed low is in blue, and the differential voltage is in green. You can see in the diagram the differential voltage is the difference between high-speed high and high-speed low. When the high-speed high is 3.5 volts, the high-speed low will be 1.5 volts, the difference being 2 volts. When the high-speed high is 2.5 volts, high-speed low will also be 2.5 volts. The difference is 0 volts. The module sees the message as 0 and 2 volts. The 2 wires in the CAN system are twisted together to help eliminate interference. Any interference introduced into the wires by electric or magnetic fields tends to couple both wires. As the noise affects both circuits equally, it is cancelled out at the control module, where the signal difference is processed. The DLC connector within a vehicle comes as standard, where the high-speed high pin is located at pin 6 and the high-speed low pin is at 14. You should have 60 ohms at these 2 pins when the system is asleep. The CAN bus goes to sleep when you lock your vehicle or leave it unattended for a long period of time. This can be up to 20 minutes or more, depending on the vehicle. In later vehicles, the bus will wake up when you unlock, open a door, or even insert a key, where back in the earlier vehicles, you had to turn on the ignition. This concludes our module on the high-speed bus network. The high-speed bus can send and receive messages from multiple control units at a real-time rate. It's quite a simple system. Understanding the high-speed bus will make your diagnosis a lot easier. I hope you've enjoyed it. Thanks for watching, and bye for now.